Hello, everyone. Welcome to IoT207, Managing Devices at Scale with IoT Device Management. My name is John Jane. I'm the product manager for the service. Joining me today for this session is going to be Alex Zakharenko, over here, one of our software engineers as part of AWS IoT, as well as Joel Hensley and Zach Raymakers, who are going to be joining us from Hudl today. So our main thing that we're here to help you guys is to be able to help you solve some of your device management challenges and hopefully also save you from future headaches that you might be facing when rolling out an IoT solution. And so we're really excited that you guys are here today. We have some great new features that were actually just launched a couple weeks back. Hopefully, and those provide some extended capabilities to help you solve some of these device management challenges that you'll be facing. So let's dive right in. We'll be starting first is an overview of the service. We'll talk a little bit about some of the core challenges that we've been hearing from customers around problems they've been facing when rolling out a device management solution, some of their challenges with rolling out IoT overall. Then we'll talk a little bit through some of the existing capabilities that the service provides today. Then we'll jump into our new features, and those includes some of the new features I just mentioned that we just launched a couple weeks back. I'll describe through some of the example uses for those new features, and then we'll invite Alex over to the stage, and he'll actually walk us through a magical demo about how those new features are in play for a device management solution. And then we'll finally invite Joel and Zach, who are going to walk us through their customer story about how device management is helping them with one of their connected sports cameras. So let's first start here with the IoT architecture. And so IoT is complex, and we understand, I'm sorry about that. IoT is complex, and so there's multiple different layers or categories of how we think about IoT overall. I'm sorry, I'll put this down. On how we think about IoT overall. And so some of the main ways IoT, we don't really want to keep them going. Maybe I'll actually turn this off and go from here. Let's talk IoT. All right, so no click. Oh, you know, I'm going to skip that one. I'll just talk about it. I'm sorry that you guys can't do this one later, but the slides will be shared afterwards. You can look into, see the architecture for everything. I apologize for that, but I'll explain it through. So what the IoT architecture, what we provide it through is a few different layers. We first start with our devices layer. It's basically the bits on those devices, and one of these example services is Amazon FreeRTOS, which is our real-time operating system that works on microcontrollers. Then we move it toward what we call our control layer, and it's effectively the different cloud solutions and services that we provide for our customers. This includes IoT Core, which provides connectivity and messaging for different devices, IoT Device Management, the session that you guys are here to learn a little bit more about today, which provides fleet management capabilities for devices. And then we move up into the IoT Analytics or data space, in which IoT Analytics provides you with different ways of ingesting data, enriching data, and analyzing massive amounts of IoT data. And the reason why I want to give you guys that context, though, just to understand on where the device management service works in terms of the broader IoT ecosystem. So we can have devices that are running Amazon FreeRTOS that are being managed or connected through IoT Core, managed by IoT's device management, fleet management, such as doing over-the-air updates or organizing your different microcontroller devices. And the data that's being processed and being ingested by IoT Analytics can then be analyzed and processed, and you can gain those insights from those services that way. So now, let's jump into this slide in which around problems with managing IoT devices. And so we're diving a little bit deeper now into the device management service itself. And so these are the kind of three key themes that we've been hearing repeatedly from a lot of our customers around challenging with fleet management overall. One of the first things is dealing with scale. If you believe in some of the analyst predictions that are saying over 20 billion devices are going to be around in the overall IoT ecosystem in the next couple of years, this scale is going to be a massive problem. And so maybe if you have one device, a Raspberry Pi board that's sitting on your desk, you can plug it in serial, you can do whatever you want on it, command and control updates, it's easy. Now you have tens of devices, hundreds, tens of thousands to millions, and these are all realistic scale in the terms of IoT. You can't really plug in all 10,000 of your different boards and be able to manually update them one by one. And so one of the main things that we want to provide for device management is different types of bulk actions that you can do from both onboarding perspective, organization, as well as for over-the-air updates, so that you can tackle these problems at scale. The second part of it is gaining visibility into these devices. We're still continuing with this theme about scale and managing this fleet of devices. And so one of the core challenges as well is understanding the health of your fleet at any period of time. So I have my 10,000 devices that I'm currently managing across my overall IoT fleet. I want to know at any period of time how many of these devices are currently connected. What is the firmware version that's being on each of my different device types across all of my different devices? And so that's some of the visibility that we're wanting to provide from the device management perspective. And the final part of it is automation. And so with automation, and this kind of ties hand in hand together with the dealing of scale, in which now I can't do this manual action by one. I want to set up different automated capabilities so that if I want to set up an over-the-air update across my 10,000 devices, I can set up different controls, different gating mechanisms, and being able to set up that type of automated process so that I can help reduce the different operational workload that either my fleet managers or me myself running my fleet of IoT devices need to onboard on my own. So let's explain a little bit about some of the core existing capabilities for IoT device management so that everyone can just get a level set of some of the existing components and capabilities that we have today. We first start here on the left with what we call bulk fleet provisioning. And so what bulk fleet provisioning helps you do is be able to upload process. By process, I mean effectively provisioning and registering large amounts of different devices that can be varying in device types, varying in different attributes, and even onboarding multiple of your device certificates all at once in a singular template. So I was talking earlier about this managing devices at scale. One of the ways in which how bulk provisioning can help you with that is now you can upload your 10,000 devices all at once, regardless of the different type of devices, and get those all registered to communicate with IoT Core. The second part of it is real-time fleet indexing. And so what fleet indexing does, it gives you that visibility into the devices that you want. What we are able to do with fleet indexing is be able to ingest the different attributes that you have, either static attributes or dynamic attributes. For example, in your device registry, which is a component for IoT Core, where you can store static attributes such as your device type, the manufacturer, the hardware version, the business group that is currently owning that device, as well as your device shadow information. That can include dynamic information such as your RPM of your devices, the temperature of the different sensors that are being processed by that device. And the fleet index processes all of those and then allows you to search across all of those attributes at once across your entire fleet. So now you can execute a query that says, give me all my devices that currently have a temperature greater than 100. And I would return a list of all of my things that are currently classifying with reporting a state of greater than 100. Now we talk about device jobs. And so device jobs is the component and capability that we provide to provide over-the-air updates. And so over-the-air updates such as doing a firmware update, a software update, but we really don't bind ourselves to just those types of updates. You really can send out any type of job or action to your different devices. And so that can include a device configuration change. It can include just a remote reboot or a type of factory reset on your different devices. But the main value that we provide from a device jobs is be able to orchestrate that type of update across multiple different devices at once. I can target a group of devices or multiple groups of devices using a device job, and I can set my different controls as to how that device job gets rolled out across my different groups of devices so that I have more granular control on how that deployment gets rolled out to my entire fleet. And finally, we have fine-grained device logging and monitoring, which allows you to be able to quickly troubleshoot your different devices because we provide different metrics, such as cloud-based metrics for including connectivity, authentication, rules, and shadow metrics. And you're able to specify fine-grained control as to what level of different logs you want generated for your different groups of devices. So if you have a group of devices that are currently having problems for some kind of reason, you can pinpoint that group of devices, say, hey, show me all error logs for this group of devices, so you can quickly diagnose and audit and deep dive and troubleshoot those devices that you want to be able to help solve. So now that we've kind of laid out there, what I want to talk about now is just an example pattern of how some customers are using IoT device management, and afterwards we'll talk about some of the new features that we've recently launched as well. So first for here, we have, like I was saying, for bulk provisioning, one of the first things that customers can do is be able to onboard multiple different devices at scale. So in my example graphic here, I have my light bulbs, my door locks, and temperature sensors. I can upload all of that information at once, provision all of that data at once in my singular template, and we do all that work for you at provisioning all of those different devices and get that registered with IoT Core. So now that I have my devices onboarded with Core, I can now organize them and use real-time fleet indexing to be able to find and target these individual devices. And so device organization, I can use what we call device groups. And so in here, I've now organized my different devices into my light bulb group, my door lock group, my temperature sensors, and my standard devices. But really, this grouping flexibility is completely up to you. If you want to be able to group your devices by business owner, for example, that's something you can definitely do as well. But for simplicity's sake, we're just doing this one by device type. But once I've organized my different devices this way, if I want to be able to pinpoint specific subsets of devices across my fleet, that's what I would do with fleet indexing. So let's say here that these 4 devices, I've searched for them and they're misbehaving for some reason, or let's just say that they're currently disconnected. I can run a query across these different devices to be able to pinpoint and target these subset of devices. So I can either deep dive audit them or run some type of command across them or send out a firmware update across these devices so I can get them back into a good working state. And now that I have this organization set up, I just mentioned this earlier, but basically we can push out these over-the-air updates across this subset of devices, but I can also target my groups of devices for other types of actions, such as pushing out my remote reboot that I was given as another example as well. So now let's jump into some of the new features and functionalities that we just launched and how that ties into solving some of the challenges I was mentioned earlier around the scalability, the visibility, and the automation of functionality. So I've given you already a brief explanation of what fleet indexing does. I talked about the registry and shadow being ingested into the fleet index, and you can run queries upon this to be able to find your different devices. One of the main things that we just launched is connectivity information as well across the fleet index. So one of the things you can now search for is to be able to say, are my devices connected or not? Give me all my devices that are currently connected. For this particular device 123, is it connected or disconnected? And then the way that this works is effectively with your different devices, and here is my example of door lock A and door lock B, as they're connected over to IoT Core, the message broker emits different lifecycle events as they're connected over to our message broker, and we're able to ingest those different device lifecycle events and keep a store of those within the fleet index so you can search across that connectivity across your fleet of devices. And so my quick example here towards the bottom is, if thing name is door lock star, so I'm looking for all my different door locks that are currently across my fleet. If my connection state is currently true and lock status is yes, return all of my devices that meet that criteria. And so you can see from this example here, though, that this is a combination of these different types of attributes I was mentioning, both from the static attributes that might be in your registry, such as the manufacturer. It's not the example here, but thing named door lock could be something in the registry. The shadow reported lock state of my lock is also something you can query across at the same time, as well as the connection state. So any of these combination of these 3 different data sources can be combined together in a singular query across their fleet index. So some of the examples of how you can use connectivity indexing. One of the things here, for example, is let's say I just onboarded a bunch of connected smart cameras, and I want to know right now, are they actually connected? Now I can be able to search across with Fleet Index, give me all my smart cameras that are currently disconnected, and so I can pinpoint and find, okay, hey, here my 50% or this subset of cameras are currently wrong. I can go deep dive and debug and see what's going on there. Another thing you could also do is also just enable like your customer success or customer support team, for example. Let's say you have a customer who calls in and says, hey, I have a problem with this device. Now, what you can empower for your customer support team is being able to search up for that device's information, get state information such as, what is the firmware version that device is currently running on. You can get the connection state as well to be able to say, hey, actually, it looks like your device isn't connected for some reason. Can you check your Wi-Fi and your Ethernet cable for your device as well? So it helps reduce some of the support timelines that you might have from a customer support team. Now let's talk about the next feature that we just launched out for fleet indexing. And so I gave down a breakout of registry, shadow, and connectivity information that are now the main data sources that you can have processed within the fleet index, and I can query across my fleet index to get that subset of targeted devices at any time. Now what we've actually provided as well is dynamic thing groups. So I talked earlier about, I can have this concept of dynamic groups, about device groups, where I can organize my different devices by device type and or by business user. But now what I can process with my fleet index is use a fleet index query to use that to define a group membership. And so what I mean by this is, give you a couple examples here. Let's say I have my query that says, and I was talking about earlier, give me all my devices that are currently disconnected. I can use that all devices are currently disconnected and define that as a thing group. And so my thing group, dynamic thing group 123, now contains all devices that are disconnected. And let's say, for example, my door lock now comes back online, but my generic device now comes offline, it'll automatically be processed within that dynamic group itself. And so we do all that work to be able to track the different state and the criteria that you're setting up for this dynamic group so that we can automate that organization of your different devices. So this is a new mechanism in which you can use your different organization for your devices using different types of business logic that you might have, and or just targeting different criteria for a shadow state or a more ephemeral state for your different devices for organization instead of purely from something that might be more static, and or manually managing of adding in and removing devices on your own. Dynamic thing groups does that for you. So some examples here. Here's one, create all group of my bedside monitors on hardware version 1.1 in Austin that were recently connected. And so we see from the example query here, I have my attributes types, my bed monitors, my attribute version is 1.1, attribute location is Austin, with a connection state as currently true. And so I define that as my query to define my dynamic thing group. And now any device that matches that criteria will automatically get added to that thing group. And one of the powerful things of using this automation of organization is a combination of this with jobs. And so let's say, for example, I want to update and track my Wi-Fi routers executing multiple steps for a firmware update. I can now connect my dynamic thing groups, which are now tracking against the different states of my firmware versions, connect those with different continuous jobs. And so what a continuous job is, for example, is a firmware update that you send out to your devices that is a long-lived update. And anytime a device is added to that group for that job, it'll automatically receive this firmware update. So now you can see this example. As you can see, I have my different groups, firmware 1.1, firmware 1.2, firmware 2.1, connected with continuous jobs. And so anytime a device comes on board on firmware version 1.1, it'll automatically receive my continuous job update to 1.2. And then once it goes into 1.2, it's now in my secondary dynamic group, which now gets another firmware update over into 2.1. So once again, tying to that theme of automation of your different processes, this is where you can use dynamic thing groups to be able to automate the organization, and then use that together to also do different automations for your different firmware updates or remote actions as well. Now let's talk about some of the new features that we've launched out for jobs. And so once again, for jobs, fundamental capability is being able to deploy out remote actions for your devices, core use cases being firmware or software updates. Some of the existing functionalities that we provide for jobs today includes setting your velocity of your update. I can set it to say 100 things per minute being updated to have a more slow rollout deployment across my different devices. Or if it needs to be an emergency patch, I can set it to 1,000 things per minute so I can roll it out as quickly as possible, as well as getting individual status updates for each of my device executions. So let's say I rolled out a device update to 1,000 devices. I can individually see for each device to say, is it currently in progress? Is it currently executing my different update? And my devices can also provide status updates or status details as they execute to either provide you with information around the current percentage of that completion of that update, and or if it triggers some type of error while executing that update, that's also additional auditing information that you can know. And then finally, the events for jobs, which provides you with different mechanisms of being able to chain together the status of your different jobs, because we emit different MQTT events for your jobs, so that if a job completes, you can chain that together with a Lambda function to do whatever you want. Just gives you an additional flexibility of control over your different fleets. But one of the first things that we've launched that are extending out this jobs capability is our integration with code signing. So not privacy, but security, and privacy is also a major priority for AWS as well, but security is a key priority for AWS. And so what we wanted to do with code signing, especially with the concerns around security with IoT, is be able to help you be able to sign your different files before they're distributed out to your devices to help protect your devices from potential bad actors or protect your devices from a compromise. So how does code signing work? Let's just walk through quickly a workflow of how that code signing process happens. And so one of the first things is you can sign your files before distribution. And so what we provide for you, either using the console and or our APIs for signing, you would have your original code file. You would provide one of your signing certificates, and then we do that work to be able to sign that file for you. And that code signing signature, that signed file, includes a few details such as an encrypted hash, the hash algorithm that we use to be able to sign that file, as well as the original code location that your device is going to be able to pull from. And then you can take that signed code file and distribute it out to your devices using a job. And so once that device has this update, or sorry, this signed code file, demonstrated by our connected card device here, now the device is able to do a validation on that signature. And so that validation consists of two parts. First, you take that signature, you're able to use the public key that's provided on your device already to be able to decrypt the encrypted hash. And then you take the original code, use the hash function that's provided within our signature, and then you can match the two different hashes between the signature and what you've now processed with the original code. And those two are matching. Now you've validated that the person who has published this code signing file is actually the one that is you. And so you can validate that this device or this update or this code file is not compromised before getting executed on your device. And so the ways that we make this easier for you is a few things. One of them is just easy integration with our console. So all you need to do within a job file itself or a job document is provide this placeholder URL that points to an S3 bucket. You could process. We have a separate service for code signing service where you'll create a code signing profile. And then we'll take this placeholder URL, do that processing on that signature, put that signature on the device, send that signed file out to your different device, and then we will provide an example agent on your devices as well to be able to help handle the validation of that signature on your device as well. Now, the second thing that we also provided for jobs, I talked about the extension from the security standpoint from jobs, but now we're also providing more functionality for the control of velocity of that deployment of that update. So there's a few key capabilities that we're now launching as a part of device management. And the first thing for what we're calling fleet rollouts or dynamic rollouts, first one is configuring a variable or exponentially increasing rate of rollout for your update. So this is a really common ask that we've heard from a lot of customers who want to be able to say, I want my first batch or stages of my update to be processed very slowly, and only after I see successes on those first initial batches of my devices do I want to ramp up my update over time. And the reason why you would do that is minimizing different blast radius. If something goes wrong, you can control that set of devices that have now received that bad update and roll that back. And then the second part of it, though, as well as providing different mechanisms for controlling blast radius, is setting abort criteria. So now you can also set up failure thresholds for your different jobs to say, for example, if greater than 10% of my devices that are being processed either fail my update or time out from my update, then stop the entire job. So instead of you now needing to have some person watching this update 24 hours, watching it through stage by stage, you can pre-configure and preset some of these different boundaries or thresholds on that failure so that you can be ensured that, hey, if my devices or if this update that I'm rolling out to my different devices, greater than 5% of them have failed, or greater than 10% have failed, we will do the work to automatically cancel that job for you so you don't need to manually make sure that you're always watching it at all times. So how does this work? Here's just a quick diagram example just to walk you through it. So let's say I have my group of Alexa devices on the left. I have configured a job. I want to push out a new firmware update to all my devices. Now what I can set is my different stages of these different devices. And so as you can see, what I've set for as my stages is my incremental rollout or incremental rate of rollout increase across my stages. So I'm rolling it out at 10 things per minute. Then after those devices are successful, then I'm going to roll it out at 20 things per minute, then 40 things per minute, and then 80 things per minute. So you can see that ramp up, that exponential ramp up of that deployment of this firmware update to my devices. And then talking about the abort criteria, or the error thresholds that I can set up as well, let's say that 3 of my devices, while rolling out through my 3rd stage of my devices, have failed for some reason. I can set up my abort criteria, and so I'm setting it to say, hey, cancel if greater than 20% of my devices fail, rejected, or timed out for this update. And now, after I've gone through my stage 3 of this deployment, my stage 4 won't actually be processed and rolled out to my additional devices because we've already proactively canceled that device because we've detected that it's past that error threshold. So that's a breakdown of some of the new features that we've launched just recently. And now I'm going to invite to the stage Alex Zakharenko, who's going to walk us through a demo of some of these different features.
Thank you, John. Hold on. 1 second. So while the demo is preparing, so every year for our reInvent, we try to make it the best experience for all attendees as possible. And one of the frequent complaints we heard about is that transportation between venues is sometimes hard. It's not optimal. So we thought, what could we do about it? Like run more shuttles, like make ride share, scooters. But this year we decided to go with some more magical solutions. We deployed a fleet of rainbow unicorns that, that would allow people to go between these venues. However, there was a problem. Unfortunately, due to some last-minute changes in the firmware, they were deployed as a wrong firmware version was deployed. And this unicorns turned into plain horses. So today, we are going to fix this problem using this new features that John just introduced for our fleet for device management. So we are going to roll out a new firmware version for unicorns that will, for our horses that will turn them back into unicorns. So before going with the demo, let me quickly walk you through the architecture that we are going to use. So all our devices are connected to the IoT core. Sometimes they are connected, sometimes they are not, as Hudl Wi-Fi connection is spotty sometimes. So once the device is connected, it reports its state, including its firmware version, into the device shadow. And we use a fleet indexing to pick up the devices that are ready to update, which means that they are on the old firmware version, on the horse firmware version. They are currently connected, and they're of a correct device type. And then we will run a continuous job to actually push the firmware update to our fleet of the devices. Once the device will receive information that it needs to update the firmware, it will download the payload file from S3, and it will validate that the payload is indeed valid. And it will apply the firmware update, reporting new updated version of the firmware back to the shadow. So I think now, let me switch to the demo. So here is a map where we have some of these horses. Dark horses are disconnected ones, and some of them are currently connected. And we will see how they turn into the unicorns now. So let me get to the console. And I already pre-created a dynamic theme group that contains the update targets for our job. Let me open it. In this query, it contains all conditions I already mentioned. So devices are connected, and the firmware version that is reported in the shadow is a horse. So we can see that there are some things already there because some devices are currently online. So now let's go and create a job to update this horses. Let's make it simple. Firmware update. We are selecting the group I already showed. Rate targets. So now we are selecting a job file that we will use. And for a second, let's go and take a look at this file. So as you see, it has a firmware version, and it has information about the payloads that device, that our horse needs to download to become a rainbow unicorn. And also there is a placeholder for a signature that will be automatically created and replaced with the right signature for the payload. So yeah, we want to use a pre-signing URL so our firmware won't be like publicly accessible to everyone. And we want to use a code signing. I previously created a code signing profile that we just select right now. And the last important thing, we want to run it as a continuous job. So all new devices that will come online after we initiate the job will also be included in the update. So going to the next page, we see that settings that John told us about. We want a safe deployment, so we want to use the exponential rollout schedule. Let's say we start pretty fast for the purpose of this demo. We start with 100 devices per minute, but everyone can go slower. And we say that every 60 devices that are successfully updated will cause this exponential increase. We can have a preview of this. We can see a preview of this update schedule. We also could configure a job abort configuration, but we are not going to do this right now. It's possible based on the number of failed or timed out devices. So now let's start this job. First thing is that the payload is updated with the signature that is generated. And here is some information about the jobs. You see that some devices are already successfully updated, which we can clearly see on the map. Some of these horses turned into unicorns. And let's bring some more devices online to see how all our fleet turns into unicorns, maybe in a few, in some seconds. Okay. Yeah. Yeah, more devices are coming online, and they immediately receive this information, how to update them to unicorns. So yeah, I think we saved the day, and we brought back some magic to the reinvent transportation. Yeah, with this, I hand back to John.
Thank you, Alex, for that magical and wonderful demo. Saving us from the horrors of reinvent transportation is definitely a little bit painful, but hopefully our unicorns can fly us away to between venues. So next, we want to invite, sorry. Oh, I'm actually, there we go. Let us invite Hudl to the stage. I'd like to get Joel and Zach, who are going to walk us both through a demo of their sports camera. Really excited about this one. And they're also going to be sharing a little bit about the customer story about how they're using device management today. So please welcome Joel and Zach.
Thanks, John. As John mentioned, my name is Zach Raymakers, and with me is Joel Hensley. We're software engineers from Hudl, a sports software company based in Lincoln, Nebraska. We have a vision of capturing and bringing value to every moment in sports. Our platform allows teams to record, upload, break down, and share video. We have teams that range from youth club teams to the most elite professional teams in the world. We have over 40,000 basketball teams that use our product, and 98% of US high school football teams use it as well. And for a glimpse into the scale that we operate in, on a typical Friday night during the US high school football season, 38 hours of video are uploaded to Hudl every minute, and on the following Saturday mornings, 220 hours of video are watched on Hudl every minute. But capturing good video for high school teams is hard. They have to find someone to record the game, hope they don't get distracted and miss part of the play, and then deal with the hassle of uploading the video after the game is over. To help teams solve this problem, we released a new beta product this year called Hudl Focus. Hudl Focus is a mounted camera solution that captures HD video from the perfect angle with no cameraman required. The camera syncs with the team's schedule on Hudl and will automatically start recording and uploading in real time. We have a dedicated mobile app, which allows teams to have easy self-installation and control of the camera as well. Now, in order for this device to scale for us, we need to continue to provide the same level of world-class support that our coaches have come to expect. And that's where the power of IoT came in for us. IoT allowed us to enable two-way communication between the device and Hudl, and therefore we can perform remote updates, do health checks, and troubleshoot a single device or the entire fleet. We operate on school networks, which are often unreliable, and IoT gave us the reassurance that as soon as the device came back online, we would be able to connect to it and have it operate without any data loss. So our device is a single unit that has 4 camera sensors. We have custom designed boards and firmware that allow us to control those sensors, and from those raw streams, we create a 3D world in which we can create and control multiple virtual cameras. Now, these cameras could be intelligent and follow the play back and forth using player and object detection like you see in this video, or it could be a static view of just a portion of the court used for practice purposes. We can record and upload multiple streams from a single camera at the same time, and after uploading to Hudl, the coaches can watch the video back and switch between these different angles. Now, Joel's gonna tell us a little bit about the system that allows this to happen.
Thanks, Zach. All right, so let's start off at a high level, and you can see some primary actors in our system. So on the left side of the screen is the Hudl Focus camera. There's a number of different layers of software that are inside of the camera. It runs a full OS, there's imaging processing, communication layers, and together we kind of call it the camera software. On the right side, you'll see Hudl.com is our web layer. It's an established API. We have mobile apps that connect to it, live for information. There's video players on top of it. And the API works really well for one-way communication and mobile apps. But when you start introducing physical devices that are unreliable, they need to be able to communicate back and forth and receive payloads, it gets really difficult, and that's where IoT comes in. So let's look at that. So on the left side, our backend is powered by .NET Core, and we use that to connect to IoT. On the right side, the devices are running Python, and they connect to IoT that way. I think a good way to kind of show off how we're using IoT is to kind of walk through the life cycle of the product. So when the device first arrives and it's assembled, we've got to provision it, we've got to get the device registered with IoT. So what we'll do is we'll create a certificate, put it on the device, and we'll invoke a Lambda that then associates that device to the certificate and then performs just-in-time registration. Great, so now we need to send out the unit. Once a school buys one, we need to associate that school to that installation of the device, and that's done via the shadow state. And so what we'll do is we'll store a number of configuration values, information for how to access the Hudl API, current status and state that it's in, and that'll get synced to the device when it connects online. Now the device arrives at the school, they put it up on the wall, it looks pretty good. They have to then tell someone on our team to calibrate and configure the camera with the 4 sensors to make everything look really good and clean. There's a lot of data that goes in there. It's not a simple small file to do all the calibrations required. So for those scenarios, we actually use an S3 file to store all that information and then store a pointer back to that file on the shadow state with a version. And if that file ever changes or we make changes to the calibration, the version will update, the shadow state delta will get fired, and the device can download the new file and apply the changes right away. Okay, so that's all done. The device is online, it's activated, it's configured. We want to start using it, right? We want to record video. That's where jobs come in. Jobs allow us to perform remote actions on that device. And so we can schedule a start recording job. The device will turn on, start recording. We can say stop recording, it'll stop recording. And all that's done via jobs. And if the device comes offline for a while and then comes back online, it'll read that job and process it right away. Next, I want to talk about some of the tools we had to build for managing the fleet. So as Zach mentioned, these devices are spread across schools all over the country. We need to have a way to monitor these devices, perform remote actions, and really provide the world-class support that Hudl provides all of our customers. And so what you're seeing here is an internal admin page that we built that displays some basic information about the device. But the really key thing I want to show you here is the actions that we're able to provide to our support team with one click of the button. If they want to check the sensors, they can request screenshots. That goes through an IoT job. If they need to reboot the device for some reason, they click a button and do that. All of that's powered through jobs, which enables us to do that without having to have them learn a lot of things behind the scenes that are going on. But one of the most important features really is releasing new software updates. Updates are really important. At Hudl, we like to move fast. We like to release changes as soon as possible. We're currently on a 1-week release cycle. So that means every week we have new changes, new code that we want to put on these devices. How do we do that safely and effectively across our fleet? So we have this update button. And when we had, 10, 20 devices, it was pretty easy to click a button each time to send an update to a device and go through. That was fine. But as you get to hundreds of devices, thousands of devices, hundreds of thousands of devices, you can't click a button for every single one, and that's where jobs come in. So when our jobs, we actually will target an entire group of devices, but not all devices are ready for updates. Some devices are still sitting in a warehouse, some devices are not installed at the school, so we want to only target devices that are online, have been calibrated and ready to use. And so for that, we programmatically add devices to a subsetted group called activated devices. And that allows us then to release targeted updates just to that group. And we're really excited to take advantage of dynamic thin groups that John and Alex mentioned so that we don't have to programmatically do that in the future. So I want to give you a visual example of what this looks like. So we have our devices across the country. You click the button, and immediately they're getting that job. They're processing it. If the device is offline for some reason, it'll pick it up when it comes back online. It'll download the payload, update all the device software, and reboot it normally. So I want to show a real quick example on our device here. Zach has a phone. He's going to issue an update command, and if the device receives it, it should turn blue and start flashing. Hopefully. And there you go. So right now it's processing that, running through the updates, and then once the update is completed, the lights will turn off. And this is going to happen, across hundreds, thousands of devices in real time. And now I'm going to go over to Jack to do another demo on recording.
Thanks, Joel. So yeah, now we're going to do a demo of how this shows up for a user. So as I mentioned, we have a dedicated mobile app that we've built. Built it entirely in React Native so we can send it out to coaches with different platforms of devices. So coaches can see a live view of their gym, or they can see any upcoming recordings that they have based on the schedule that they've previously entered into Hudl. They can also do an on-demand recording, and when they do that, it will create an API call to Hudl, which then triggers that job to be sent to the device. So we'll go ahead and do that now. We'll start a recording. We'll use the defaults here. The job will be sent, and within a couple seconds, the device should start recording. The lights will turn green, letting the user know that it's recording. Like we've mentioned several times, these devices are in schools that have notoriously bad internet connections. That could be flakiness, that could be an IT admin changing settings during the day, or it could be someone seeing an Ethernet port plugged in, they need access to it, they'll unplug our camera and never touch it again. IoT gives us that reassurance that as soon as it comes back online, any queued up jobs will be received, any shadow state updates will be waiting for it, and it will continue on as if nothing ever happened. They can also stop the recording if they want to, again triggering an IoT job, which will stop the recording and upload to their Hudl account. Because we upload in real time, the video is watchable on Hudl within a couple minutes after the recording is complete. So this has been an exciting beta season for us so far. We've worked closely with AWS and IoT to help this be successful. And we look forward to releasing Hudl Focus for general availability next year for our teams, and we'll continue to work with IoT to help us scale. Thanks.
Thank you, Joel and Zach. It was an awesome demo. Hope you guys don't mind being on camera if you guys actually didn't tell. That was actually going live, recording all of you guys. It's okay though, we couldn't see you guys. But really appreciate it. It's always fantastic to see an actual usage from a customer and showing how they can actually implement and use device management to help succeed within their business, and also being able to provide that world-class support they were mentioning of being able to give that to their different coaches all the time. And so what I'd like to do, just a few more words, just summarizing and wrapping up the main things that we've talked about in this session so far. So first, we opened it up with an overview of the different service, about device management, how are the core capabilities, how does that work. We talked about some of the core challenges that we're looking to tackle with the device management. We talked about the scale problem. We talked about the visibility problem, as well as the automation issues. Then we discussed a little bit about some of the new features that we launched to tackle those core issues. Connectivity indexing gives you that more visibility into your different devices. Is my device connected? Is it disconnected? Get a little bit more insight into that fleet health that a lot of our customers are asking for. Then dynamic thing groups gives you that organizational automation so that you, instead of needing to distinctly or directly manage of adding or removing devices from your groups, you use a query to automate that organization and use those queries to chain those together with different jobs so you can roll forward with different types of automated deployments to your different devices. We talked about code signing with jobs, which enhances the security of your different devices, of being able to validate that it is you who's sending out that device update before your device executes it. And then about jobs dynamic rollouts, of giving these new fine-grained controls of doing the slow deployment, different controls around setting up abort thresholds or failure criteria for your devices to have more minimization and mitigation for potential bad updates to reduce the blast radius that you might be able to have within a device update. Then Alex came on stage to walk us through his magical unicorn demo, which is helping us save the reinvent of transportation. And then finally, we had Joel and Zach, who were able to walk us through their fantastic demo for their Hudl camera. So thanks very much for joining here, guys. Just a few things around how to get started. If you're interested in IoT device management, there's a few really easy ways to get working with it. First one, IoT console. All of the features we talked about today are available in the console if you want to get started there. They're also available via our APIs, which are documented within our documentation. I have a few links in the next slide that you can use and refer to later on. We also have our different device SDKs, which are going to be you can use on your devices themselves to integrate with the different features and capabilities we talked about today. Within some of our device SDKs, we also provide sample agents. So if you want to either use, for example, like I was saying, for our code signing integration for your devices or just using jobs overall, we provide some sample device agents that you can use to integrate with your solution. And finally, we have a number of different blogs that have been recently published for IoT device management that can also help you get started in learning some kind of basics of how to use and integrate with device management into your IoT solution. So here's a quick slide. I'll skip through this one. This is more for your reference if you want to look at these slides later on around both an email alias. You can contact us at AWS IoT DM info. If you have any kind of questions or have any kind of needs, please feel free to reach out to us. Some more forum, developer guide, blogs, and device SDKs. But that's the end of our session. And so thank you very much for joining. I hope you guys enjoyed the session. Thank you again for Alex, Joel, and Zach for joining us today as well. I hope you guys enjoyed it.